Good day everyone, this is our chapter 4, Relative Equilibrium of Liquids with its subtopic Rectilinear Translation. Problem 1. A rectangular tank 20 meter long, 8 meter wide, and 6 meter deep is completely open at the top. If it is initially filled to the top, how much liquid will be spilled if it is given a horizontal acceleration of 0.6 times the gravity in the direction of its length? And number 2, what is the maximum force acting on the side opposite the direction of the acceleration? And number 3, determine the volume of the remaining water inside of the tank. But before we go and start solving our problem, let us first take a look at this illustration given to us. What is rectilinear translation? Under certain conditions, the particles of a fluid mass may have no relative motion between each other, yet the mass itself will be in motion. If a mass of the fluid is moving with a constant speed or the uniform velocity, the conditions are the same as in fluid statics, as discussed in previous chapters. But if the body is subjected to acceleration, whether translation or rotation, special treatment is required, and this will be discussed in this chapter. So, as you can see here, we can always remember that weight is equals to mass times the gravity of ms squared times the kilograms, which is kg m squared, or the Newton, the REF or the reflective force, which is mass times the acceleration, or the kilograms times the ms squared, or still force is equals to Newton. And our triangular theta and the normal force. Remember that weight is perpendicular to Earth, and normal force is perpendicular to the surface of the fluid. Rectilinear translation or moving vessel. Horizontal motion. Consider a mass of fluid moving with a linear acceleration, theta, or as shown in the figure, considering a particle in the surface. The forces acting are the weight, which is weight times mass times the gravity, and the fictitious inertia force or reversed effective force or the ref, which is equal to mass times acceleration, and reaction n, which must be normal to the surface. Volume of liquid spilled out is equals to the tan theta is equals to opposite over adjacent, which is then equals to the ref over weight, or the mass times acceleration over mass times the gravity. Cancel out mass from the upper and lower part, which is then we can have our tan theta is equals to acceleration over gravity. Tan theta is equals to 0.6 g, or the acceleration over the g of gravity. Then cancel out the g from upper and lower part, so we can have our tan theta as 0.6. Next is for us to solve for y. We have here our formula as tan theta is equals to the y over the 20 meter, which is the length of our container. To solve for our y, we can cancel out 20 meter below by multiplying it from both sides. So 20 could be multiplied to 0.6. Now, we have our y as 0.6 times 20 meter. Multiplying it, we'll have our y is equals to 12 meters. And finally, our volume spilled out will be length times width times height, which in where our length would be 20 meter plus 10 meter over 2 times the 8 meter and 6 meter. And now we will have our answer as 15 meter times 48 meters squared. Multiplying it, we will have our final answer as the volume spilled equals to 720 cubic meter. Next is solving for the maximum force acting on the side opposite to the direction of the acceleration. Solving for the force is equals to F is equals to P, or we can just use F is equals to the specific weight times the volume, which we can see here as kilonewton over cubic meter times the cubic meter of volume, cancel cubic meter, and we will have our force as the kilonewton or the newtons. Solving for our maximum force, we can use force times specific weight times the volume as 9.81 kilonewton per cubic meter as the specific weight of the water times the volume left on the container, which is 3 meters by 6 meter and 8 meter. Multiplying it, we will have 9.81 kilonewton per cubic meter times 144 cubic meter. Cancel cubic meter from both sides, and we will have our force as 1,412.64 kilonewton. Number 3, we can solve our volume remaining of water on the tank by subtracting our total volume and the volume spilled. Our total volume has a full tank of 20 meter by 6 meter and by 8 meter, which in where we will have 960 cubic meter minus our volume spilled, which is 180 cubic meter. Our remaining volume on the tank is 780 cubic meter. And that is all for our Chapter 4 Rectilinear Translation. Thank you, and I hope you have learned something from this video.